Good afternoon, Caleb here at Sunfind Solar. Welcome to another Sunfind Solar vlog. Hope you find this installment interesting. Designing and installing an off-grid system. What's important and what needs to be done to ensure that the off-grid system will operate effectively. Okay, our array has come together. It looks good here. So we have 24 335 watt modules. The solar array's function is to generate enough energy during the day to not only meet your needs, but also to charge those batteries. It's important to remember that the battery bank needs to be recharged going into the evening so you have enough energy stored in those batteries. When sizing the solar array, we are looking at daily energy consumption. So for this system, this is an 8 kilowatt solar array, and basically this system is designed 15 kilowatt hours per day. Use more than that, then there are going to be times where you need to supplement energy in the winter months with a generator. So when it comes to operating an off-grid system, we can calculate quite precisely how much energy that array is going to produce throughout each month of the year based on the latitude location of that array. There's only a finite amount of energy you're going to get from those modules during each month. It's important to know what that energy generation amount is, and then to be prepared to live within that. If the site's using more energy than what that array is producing, either you got to add more solar to build out a bigger array, or you need to run a backup generator to make up the deficit. But in some cases, consumption levels end up being a lot different than what anticipated, and so off-grid system owners have to be prepared for the possibility of adding more solar. So let's talk about this solar rack a little bit. Fixed at 45 degrees. It's a nice simple rack, just installed on screw pilings. So when it comes to rack, if you kept the solar modules perpendicular to the sun, you're going to have the best output of that array. You also have to consider the cost as well, and if stepping up to a tilt rack is worth that extra cost based on the site, the system owner, and his or her preference. So here we have our fused disconnect. It also acts as a combiner box, but basically this is our disconnect and rapid shutdown for this array. These midnight solar boxes we have found are by far the best fused discos out there, well put together and made in North America, which is fantastic. So you can see here we have all our array strings coming in. All that cable is routed and strapped. You can see it's rolling over this nice edge here, so there's no sharp edges that those conductors are going to be on. We've got it routed nice and neat along that leg. And of course, it's tucked in, strapped, and secured and run down that array to make our work stand out. Presume that there's going to be increased energy consumption over time. So right here, you can see this extra junction box here. So essentially what we've done is we've run an extra cable from the rack out here all the way back to the shop over there where the inverter system's in. It's just terminated and held for future use. Okay, we have our inverter system all wired in here and it's up and running now. So with that, I just want to talk about this inverter system a little bit, and when you're doing an off-grid system, things that you have to take into account when doing proper design work. For this system, we sat down with the client and we went over various options, both from an energy perspective and a power perspective. So power is going to be in watts, or we can break that down further into amps, and then energy is going to be in watt hours. So this is very important when doing an off-grid system, because we have to make sure, one, that the inverter system is going to provide any power loads, such as when pumps come online or other various loads just get turned on. And then two, we need to take into account the energy required that the system needs to deliver over a given amount of time. With this system, after consulting with the client, going over various different options and their expected loads, we settled on a single inverter. So this single inverter will provide 52 amps peak for a few milliseconds at 240 volts. And then we'll settle down to a continuous of 25 amps at 240 volts. In addition, this system can provide up to an 80% imbalance on each leg. Now, if the customer should expand his needs, we can add a second inverter in here or a third inverter. Keep the system integrated with the same electrical panel. We have the Sacred Sun lead carbon batteries. So these batteries are a 2-volt lead carbon, 24 of them arranged for 48 volts and 24 kilowatt hours. So again, when we're doing our batteries, we also have to take into account power and energy. So with this system, we made sure that the maximum power delivery from the batteries is in line with the customer needs. So we want to make sure all these parameters are within what's required by the customer to make sure the system works appropriately. You can add another bank into here and boost them up to 48 kilowatt hours and double that storage if need be. Control panel here. So this allows us to control the system, program it, see what's going on. This is the auto gen start, so it's connected to the generator and will allow it to start. We just put a little auxiliary plug on here. So this little auxiliary plug just allows us to have one source of power until that electrical panel is tied in. Here we have the COM box to program the system, to extract data out of the system, as well as monitor it remotely. With the inverter system here, we have two charge controllers, so they're each a 60 amp, 150 volt Schneider MPPT charge controller. Half the array ties into one charge controller, half the array ties into the other, and again with this we can expand it. Here we have our grouping of AC breakers that we use to protect the system, and then down here we have our group of PV breakers, so we have source input as well as the charge controller breakers, and here's our big master 250 amp breaker. Here we have the actual inverter, so that's it'll basically provide 52 amps peak at 240 volts and 25 amps continuous at 240 volts. And we just have a battery monitor in the system, so this accurately measures the amperage in, amperage out. And as talked about, we have our lead carbon battery bank here. So these lead carbon batteries we've been using for about the last almost 2 years now. So there you go, there's a little rundown on the inverter system, and let's run over and talk about the generator. So here we have a Kubota 12 kilowatt diesel generator tucked in the corner of the shop here. Block and battery heater, so if need be, it can be plugged in. Found this to be the absolute most reliable system available and most efficient. This generator will use a lot less fuel than a competing propane or natural gas unit. Unit's nice and compact here. Everything is accessible for maintenance when need be. We still have to get our fuel tank in place here, so you can just see it's plumbed off the jerry can. Just allow us to test and commission, make sure that it's running properly. Here we have our exhaust system. It's routed out through the wall. You can see it's all insulated in there properly, so then it will not cause any temperature issues with the wall. So here we have the control panel system, and this is actually set up for auto mode, so we can just flip this toggle switch into auto, and the solar system will control everything, start it and stop it as required. Just a breaker for the system here, compact. We can see our little electric fuel pump down there, fuel filter. There we did a quick clean of the solar modules. Presented a great opportunity to talk about snow and the modules and tilt. So as I spoke earlier in the vlog, we did mention, having a steeper solar array to help shed the snow. So this is just a real life example of the criteria that we take into account. So with this particular array, it's only tilted to 45, and the main concerns for the client were just a nice simple rack system that's very little maintenance, that stays sturdy and strong. So that's why we went with the fixed 45 degree. But as you can see, when you get a large snowfall, there's got to be about 8 inches of snow on there. So we, about 10 minutes ago, just cleaned off everything down here. And you can see how those modules, the residue snow melts off real quick. But you can see how much is up there now. I clean this off real quick. But I guess the point of it, you weigh your options between a more complicated mount that you can tilt all the way up, more cost to put that mount in, or do you just take the time to clean it off? So for this particular client, this mount was the best option, but of course we can put in mounts that are going to tilt up much steeper, that are fully adjustable, and it just depends on the client and what you want to do. So let's get the rest of that array cleaned off. All the snow is cleared off. The sun will get all the little residue left there in a few minutes, and that'll be cleaned right off. So if you don't mind cleaning the snow off once in a while, a fixed rack like that is an excellent way to go. Super reliable, simple, very little maintenance. Okay, we have the system officially up and running. We've just commissioned everything. Auto gen start works. PV array is working as it should. Inverter system is working as it should. Up to 3 hours to walk through, commission everything, watch the program, and making sure everything is doing what it's supposed to do. So there we go. Off-grid system up and running. Thank you for watching. If you'd be interested, give us a shout.